Basic Math, Chapter 9, Section 7, Adding Unlike Mixed Numbers. Unlike mixed numbers have unlike fractions. You can add unlike mixed numbers. First, rename to make like fractions, then add the like mixed numbers. For example, add 7 and 5/6 plus 3 and 1/4. Step 1, make like fractions. Use 12 as the denominator, because 12 is the least common denominator between 6 and 4. For 5/6, we can increase the 6 and 5 by multiplying by 2, and that would give us 10/12. 10/12 has the same value as 5/6. For 1/4, it takes 3 4s to get to 12, so we increased 1/4 by multiplying the 1 times 3 and 4 times 3. So 3/12 has the same value as 1/4. Now they're both like fractions with the denominator of 12. The whole numbers haven't changed, only the fractions. Step 2, add the like mixed numbers. Write the answer in lowest terms. Now that they're like fractions, we add the numerators. 10 plus 3 is 13. The denominator stays the same, 12. Add the whole number, 7 plus 3, 10. 13 over 12 is an improper fraction, so we can reduce that. It takes 1 whole 12 to go into 13 with 1 left over. So the whole 1 goes to the 10, which makes it 11, leaving us with 1/12 left over. All right, let's practice. Let's take a look at number 4 and number 8. Zoom in so we don't have to rewrite quite so much. We have 3 and 15 as the denominators for our two numbers, 8 and 2/3, 2 and 1/15. Well, the least common multiple between 3 and 15, let's see, 3, 6, 9, 12, 15. So we just need to change the thirds to 15ths. It takes 5 thirds to get to 15. So the new fraction would be 10 over 15. The whole number 8 stays the same. Nothing has changed for 2 and 1/15. Add them up. Add the fractions first. We get 11/15 and 10. So that is how we can add unlike mixed numbers. Let's take a look at number 8. We have 4 and 6 as the denominators. We need to turn those into like fractions. Multiples of 4 would be 4, 8, 12, 16, 20, 24. Multiples of 6 would be 6, 12, 18, 24. We have a couple of matches. 24 and 12 match. Let's use the first one. The least common multiple is 12. So to get to 12, we need 3 4s. So this will become 3 over 12. The whole number stays the same. And to change 6 to 12, we need 2 6s. So this becomes 10/12. The whole numbers stay the same. So we're going to have 13/12 and 15 whole. but we have an improper fraction. So the number on top can go in the shop and divide by the denominator. 1/12 can go into 13 with 1 left over. The whole number 1 gets added to the original whole number of 15. So we're going to get the whole number 16. And the fraction of 1, can't write. It's not writing anymore. There we go. 1/12 left over. So now we have it in lowest terms. All right, we have some more. Remember to write each problem in vertical form. So we've got a whole bunch more we can practice with. Let's just take a look at a couple. Start with number 13. Here we have 20 and 5 as the original denominators. So let's first start by rewriting them vertically. So 12 and 11/20. Let's make the 5 denominator into the 20 denominator because 20 and 5 have the least common multiple being 20. It takes 4 5s to get to 20. So 4 times 5 is 20, and 3 times 4 is 12. So now we have turned 3/5 into 12/20 to make like fractions. The whole number stays the same. Now we can add. In this case, we get 23. 11 plus 12 is 23 over 20. And the whole number 4 plus 12 is 16. But 23 over 20 is an improper fraction. We can fit 1 whole 20 into 23 with 3 left over. The original denominator becomes the denominator for our reduced improper fraction. We've got 1 whole and 3/20. So let's give that 1 whole to the 16. 16 plus 1 is 17. And the fraction left over is 3/20. So 17 and 3/20 is the answer to 13. All right, let's take a look at one more here. Number 19 has 2 and 5/9 plus 1 and 2/3. So we can make the thirds into ninths by multiplying the numerator and denominator by 3. And the new fraction would be 6/9. The whole number 1 stays the same. Add the numerators to get 11/9. 5 plus 6. And the whole number 2 plus 1. Again, we have an improper fraction, so we divide the fraction by putting the number on top in the shop, 11. The denominator does the dividing, in this case 9. We can fit 1 whole 9 into 11 with 2 left over. The 2 left over is out of 9 parts, so we have 2 out of 9 left over. We can give the 1 to the 3 So now the final answer will be 4 2/9. Some everyday problem solving. This neighborhood map helps people plan their routes. Use the map to answer the question. Brenda drove from Seattle to Summit, then to Sterling. How far did Brenda drive altogether? So she went from Seattle to Summit. So that is 4 1/3 miles. And then she went from Summit to Sterling. That is another 2 3/4 miles. So how far did she drive altogether? That is the math problem of, let's see here, some space. Combining the 4 1/3 miles with 2 3/4 miles. Well, the multiples of 3 and the multiples of 4, 3, 6, 9, 12, 15, 18, 4, 8, 12, 16, 20. Which one is the first match? Not 3 and 4, not 6 or 8, not 9, but 12 matches. So let's turn these two fractions into fractions with 12 as the denominator. Takes 4 3s to get to 12. So we multiply the numerator by 4 as well. 4 times 1 is 4. The original denominator stays the same. It takes 3 4s to get to 12, so we multiply the numerator also by 3. So now 3 times 3 is 9. The whole number 2 stays the same. Now we can add them, and we get 13, as we are adding the 4 to the 9. The denominator stays the same. Add the whole numbers, 4 plus 2. 13/12 is an improper fraction, so we can show that we get 1 whole 12 into 13 with 1 out of 12 left over. We give that to the whole number 6 to make it 7. The leftover is 1/12. So 7 1/12 miles. And if you'd like to practice some more in your notebook, you can take a look at 2 and 3 and 4. Number 2 has a bus route goes from Swanson to Seattle, then to Summit. How long is the route? So we're adding up the miles. So from Swanson to Seattle is 4.5 miles. And then to Summit is the 4 1/3 miles. So you'll add up the 4.5 plus 4 1/3 to find out how long that is. You can try that on your notebook, and then you can do some more practice in your workbook for Chapter 9, Section 7. Please let me know if you have any questions. Thank you.